So far, we covered two features of the functional API. The first is that it allows us to use the same graph of layers to generate multiple models. And the second feature is that the functional API models is callable, like a layer. The third features that I would like to cover is that we can actually use the functional API to capture multiple inputs and generate multiple outputs. Let's learn about it. The functional API is much more flexible for us to manipulate multiple inputs and outputs, which cannot be handled with the sequential API. Let's take a look on this example to see how we can manipulate different types of graph topologies. Let's say what we're going to do is to build a system with 3 inputs, and the first 2 inputs is a text input, and the third input is a categorical input with 10 categories. And then these models will have 2 outputs. One is a sigmoid output, and the other is a softmax output with 3 categories. We can build these models in a few lines with the use of the functional API. So first, let's set up the input and output arguments. The number of works that we are going to have is less than 100 works. So we set it up that is the number of works that could be up to 100. And then for the input categories, that is 10 categories. So we set it 10. And then for one of the outputs, that is the softmax output that have 3 categories. So we set it 3. Because we do not know how many works that we are going to have for each of the test inputs, so we can just provide a none in the shaped in the first input layer. For the test input 1, similarly for the test input 2, we also provide a none shaped in these input layers. For the categorical input, because we know that it's a 10 categories input, so for this one, for the shapes, we can provide a numbers input categories that is 10 over in this assignment. Since we have 2 text inputs, so it would be better for us to use the embedding layers to embed each word into a certain dimensional vectors. Say, for example, we are going to take these inputs, there's the number of words that is the 100 length, and returns or embed everything embed each word into a 64 dimensional vectors with these embedding layers, so that later on we can learn the features easier or better. So what we're going to do is that we will just pass these text input 1 into these embedding layers, and it will return you a text input 1 features. Similarly, we will have the text input 2 features as well. Now we're ready to learn the features. For sequential inputs to learn the feature, it would be much more effective if we use the long short-term memories or recurrent neural network. And in this example, we are going to apply the long short-term memories layers to learn the features, and it will return you a 128 dimensional vectors. That is the number of neurons that we set here. So we will pass on the text input 1 features into these long short-term memories layers with 128 dimensional vectors, and it will return you the text input 1 features. And again, we will have another set of the another layers of the long short-term memory reads that will help us to capture the features from the text input 2. Now, the next things that we can do is to concatenate or to merge all the available features into a single large vectors with the functions, with the layers of the concatenate. Now, we have the text input features 1, and the text input features 2, that is from these 2 text inputs. And then we will just directly provide this categorical input. This is the categorical input into these concatenated layers, and then it will help us to merge everything, all the features, into a single large vectors, and it will return you a X. Remember that we have a sigmoid output and also a softmax output. So the first thing is that we would like to apply a logistic regressions for predictions. For this time, we are going to have a dense layers, namely with the binary output as the sigmoid output. And for the second one is the softmax output. So we will apply a classifiers for 3 categories. And for these times, we are going to apply a dense layers again with the number of the outputs of the categories, that is 3. We just assign it here. And for this one, we will name it as the categorical output. So we have the binary predictions, and we also have the categorical predictions for the outputs. Now we have the inputs, and also we have the output, which is the binary predictions and also categorical predictions. We can then put everything into a Keras functional APIs models with the corresponding input with their corresponding outputs. And then we can run this cell to set up these multiple inputs and multiple outputs network. And then I can also run this cell to plot out the models. Now let's take a look on these models. Just like one dimensions, we are going to have 2 input layers for the text input, and then these 2 text inputs will be embedded with the use of the embedding layers. Once we embedded the words into a 64-dimensional vectors, we can then pass it on to a long short-term memories layers to learn the features. And similarly, we have another set of the text input and embeds the text into a 64-dimensional vectors and learns with the use of the long short-term memories layers. And we will have another set of the categorical inputs, and combine these all together or merge everything all together, we will have a bigger size of the output from these concatenate layers. And when we have these concatenate layers of these 170 vectors output, we will then make 2 predictions. The first one is the binary predictions, and then for the second one is a categorical predictions. When we compile the models, we can actually assign different loss functions to each of the outputs, and also we can assign different weights to each of these loss functions to calculate their total training loss. So for example, we can compile the models with the optimizers RMS pops, and then for the loss functions, we can assign different loss functions to each of their output. Say for example, because for the first one is a binary predictions, we can use the binary cost entropy. Remember that we haven't assigned the activation function in the last layer over here. So in that case, we need to set the from logics equals to true. For the second output, we can assign a categorical cost entropies and set the from logics equals to true because it's a categorical output and without any activation functions hasn't been assigned. For the last one is that we can even assign different rates. So for, say for example, the loss rate for the binary cost entropies, we can assign around 80% the contributions, And then for the categorical cost entries, we can assign 20% contributions to the final total loss. Because we already assigned different names for the output, we can also use a dictionary to specify the loss and also the loss weight to these with the use of their corresponding layer's name. So for example, for the binary output, we can use a dictionary and we can provide which types of loss functions that we would like to have. And then for the categorical output, we can use their names and then we can assign what kind of loss functions that we would like to have. For the loss weight, we can similarly use the dictionary with the use their names and provide their corresponding weights. Now, let's say, for example, if I run this cell or if I run this cells and everything has been just done. To complete this exercise, let's pass some random inputs and random outputs to train the models. Let's say, for example, we provide the text input with a random integers. Also for the text input with a text input 2 with a random integers. And then for the categorical input, we'll also pass it on with a random integer. And then for the binary target or categorical target, we also assign some random numbers and also random integers for each of them. And we will then just use the model fit to fit the functions with 2 epochs as an exercise. So we do not want to train too many times. If I run this cell, it will start train the models. And now you can see that the overall loss is 0.9, which is a combination between the binary output loss and also the categorical output loss. And that's it for this video. We just learned how to create multiple inputs and multiple output models. Now you can manipulate different types of topologies to fit into different types of problems. In the next video, we will talk more about some other useful features. See you in the next video. Bye-bye.